Our video today is going to take us through greatest common factor and least common multiple. We've kind of already covered greatest common factors, so we're not going to spend a lot of time on this one, so we're going to kind of go the other route. But again, the greatest common factor is, because it's going to come back up in this video, largest number that is a common divisor of a given set of numbers. So once you divide them out, there should be a common number that pops up. That's it. So if you need to, go back to the last video, kind of review the notes. We're going to go back to using the grid system that we showed you, or I showed you in the last video. So the one we're going to take time on today is the least common multiple. And the least common multiple is defined as the smallest number that is a common multiple of a given set of numbers. So what we're going to do is we're going to break our numbers down, or break the numbers given into primes. There's a couple different ways that I'm going to show you how to do this. You can use the grid again. It's going to be different than greatest common factor, and I'll show you that as we go through that. So let's get started with what we got to do today. So when we find our least common multiple, and we'll go 30 and 24, we're going to break these down in primes using the prime factor tree. So that's not new. That's something new. That's something that we've already done. We're going to put our numbers in, and again, with the grid system, once you put a number up there, it's got to be the same number in that system, and so forth. If you don't, move it over a column, so your columns could get rather large depending on the numbers that you're working with. So when we come up with 24 and 30, we're going to come up with the factors here. And then what we're going to do is we're going to, instead of, and this is one of the biggest difference, with the greatest common factor, we would only bring down these two columns because they're the filled ones. With least common multiple, we're going to bring down all of the columns. So you'll notice the arrows here coming down. We're bringing the value of that column down. So we have 2 times 3 times 5 times 2 times 2. We're going to multiply those together. So you're going to multiply these together, and that's going to come up with a common multiple of 120. So if you're asked to find the least common multiple, use the grid, break it into primes using the prime factor tree, come up with bringing all of them down, multiplying across as you go. So if we go 3 numbers, you can go 5 numbers, you can go any numbers that you want. 6, 9, and 12. So again, we're breaking 2 and 3, 3 and 3, 2, 3, and 2. So we're going to bring the value of that columns down. So we have 2 times 3 times 3 times 2. So when we go to the factor tree, that gives us this. We don't want to put any 0 or 1 in. And when we come up with this one, it's going to be a factor of a least common multiple. 2 times 3, which is 6. 3 times 2, 6. So it's 6 times 6. So we get 36 for this grid system. So the least common multiple for 9, 6, and 12 is 36. One more. 7, 14, 21. So we notice that if this was the greatest common factor, 7 would be our greatest common factor because it goes into all 3 of them. But because we're dealing with least common multiple, we're bringing again down the columns, multiplying those, and that gives us a 42. So the work here is we're doing the prime factor trees. Notice I didn't put the 1 because 1 is not prime, nor composite. And we don't put it in the grid system either. So we put those in using the prime factor trees, bring down all the columns, multiply it through. This is going to lead us into the fraction part. So types of fractions, we have 3 of them. We have a proper, improper, and a mixed number as we go through this. So a proper fraction is the numerator, which is the top, is smaller than the denominator, which is the bottom. Here's some examples: 4 fifths, 7 ninths, 14 sevenths. So again, the numerator is smaller than the denominator. Improper, kind of reverse. The numerator is larger than the denominator. So 9 sevenths, 14 fifths, 5 thirds. So again, the numerator is bigger than that. Mixed number, we have a combination of 2 things. We have a combination of a whole number and of a proper fraction. You cannot have an improper fraction here. You'd have to reduce it, which means you'd have to change it again. So it would be 4 and 2 thirds, 2 and 3 fourths, 5 and 9 14ths. So we have our whole number along with our fraction. So you're going to be asked to identify those as you go through the assignments. So when we simplify those fractions, whether it's an improper or a proper fraction, there's two different ways that you can do this. One is you can find the greatest common factor, so we're pulling in the information from the last video, and then we divide by that greatest common factor. So in this case, again, I use the grid system as quickly as I can to break these down into primes. With the grid, we do the greatest common factor. We're just bringing the columns that are filled. We would multiply those together, and we find that the greatest common factor is 12. We would divide that into 48 and 60. So do whatever you do to the top, you have to do the bottom. So that's 4/5 as a reduction. So we're dividing. When we divide, we make things smaller. Okay? So the other way that you can do it is, and I've had students that found this easier to do, take the primes, list them out, line them up over top of each other. The ones that are the same will reduce to 1. 3 divided by 3 is 1. 2 divided by 2 is 1. So these would go away, and what I'm left with is what I'm going to be answering anyway. So I'd multiply 2 times 2, give me 4. 5 is the bottom denominator, so we get 4/5. So I'm giving you a couple choices that you can use. So in the bottom fraction, 285 over 75. So we have an improper fraction. Leave it as an improper fraction. We found that using the grid, that our common factors is 15. 3 and 5 were the filled columns. So we divide each of these by 15. When I divide that, I get 19/5. So I can take this information and put it over here if I want to do that. Realistically, you could probably do it in the grid as well in setting this up like this. So you'd have 3 and 5, 3 and 5, those would reduce to 1. You're left with 19/5, so you come up with the same answer. So again, giving you choices in what you can do in regards to finding the answer. Let's try one more. We have 30 over 36. So again, we gridded it out. Found that our common factor is 6. So we're going to divide by 6, which gives us 5/6. If we do it by primes, the 2's and the 3's would reduce to 1. We're left with 5 over 2 times 3, which gives us the 6. So giving you a choice, use which one you want that you think is easier. If you want to do this part as a part of the grid, that's fine as well. So one of the things that they're going to ask you to do is find equivalent fractions. Well, in a sense, this and this answer is an equivalent fraction. They're equal, meaning they're the same. So there's a couple ways that you can find them. One is you can multiply the numerator and denominator by the same number. The other way is divide the numerator and denominator by the same number. Now this is only when you have big numbers that you want to maybe break down smaller, but you don't have to. You can find it by multiplying. So like we said up here, this is a way of finding an equivalent fraction. So 30/36 is equivalent to 5/6 because we divided by the large, or by the common factor. So what you want to do is you basically want to pick a number, but you want to be nice to yourself. I mean, I could pick any number I want, but I'm not going to pick 4,350. I'm going to pick a 2, a 3, a 4. I don't want to multiply by 1 because it's the same thing. It's not going to give me anything. So if I take 11 over 2 and I multiply both top and bottom by 2, I get 22/4. Or I could take it times 3 and come up with 33 over 6, which is another equivalent. So the ones in red here are equivalents. We started with 11 over 2. Or I can go and divide it and go the opposite direction. So I can divide it by, in this case, 11. Again, common factor. So if I divide it, I get 2/4. Now if I wanted to, I could divide this again by 2 and get 1/2. And that would give me basically 2 common or equivalent fractions. I could take this and I can multiply 2/4 times 2 and get 4/8. Again, equivalent. As long as you're dealing with the same number, whether you're multiplying or dividing, you're fine with that. And that's going to be able to work you through that one pretty simply. So again, when you do your assignments, give yourself a hint here. Look at the question's fraction. See if you can find a number that they multiply, making it bigger, or divide, making it smaller, will help you. So look at your answers. use them against your problem as you go through this. Our last little section is just changing improper fractions to mixed and mixed numbers to impropers. So again, when we're doing impropers to mixed numbers, we have a numerator larger than a denominator, so we're going to divide. So we're going to read this like a sentence going down. So it's 12 divided by 7. So our numerator goes inside, the denominator is outside. So we're going to divide this in until we're done with the first division, and that sets up our fraction. So our top number is always our whole number, our remainder is always our numerator, and what our denominator is going to be the same. So here's a little form for you that you can use. So if this is my fraction, A goes inside, that's the numerator, B is on the outside. I subtract it by what I multiply here. The difference is my numerator. Denominator is my denominator here. Whole number is what goes in front. So this kind of gives you a setup of where things go in the fractional problem when you divide it. When we go the other direction, mixed number to improper, we have a whole number and a proper fraction. We're going to take 2 times 3 plus 2, and it's going to be over the denominator that we started with. So again, our denominator stays the same in the problem. So again, here's a little bit of a setup for you. Whole number, numerator, denominator. Whole number times denominator plus numerator. Whatever that answer is goes on over your denominator, that stays the same. So we went through a lot of stuff in this video, but it's a lot of stuff that I think should not be too difficult for you to do. So a few hints to finish up and wrap everything up. Least common multiple, grid it out. All columns you bring down and then multiply. Simplifying your fractions, you have 2 ways you can do it. You can find the greatest common factor, divide it out, or you can set it up as primes. In this case, you can use the grid again, and then reduce it. Reduce the ones that are the same top and bottom, and that would take care of it. For equivalence, multiply or divide the numerator and denominator by the same number. If you divide, you may only need to do this once. So improper to mixed, which we just covered, divide. We're going to take our numerator, put inside, denominator outside, divide it through. Mixed number to improper, your whole number times your denominator plus your numerator. And again, you're going to put it over the denominator that you started with. So in both cases in here, the denominator is exactly the same. So again, take your notes, use them wisely, ask questions, and good luck.